Today we apply Ohm's law to calculate voltage, current, and resistance in series and parallel circuits. Voltage equal to the current I measured in amps multiplied by the resistance R in ohms, and from this relationship we can also get that the current I is equal to the voltage V divided by the resistance R, and that the resistance R is equal to the voltage V divided by the current I. Let's move now to our open access simulation courtesy of the good people at Phet, Colorado, and let's set up a series circuit with a battery, one resistor, a simple circuit with one resistor and one battery, 9 volts measured across the circuit, voltage being measured across. And now if we put our ammeter to measure current through, we see that there's a current 0.9 amps through the circuit. Putting in another resistor in series with this one, we now have two 10 ohms resistors connected in series in this circuit with the battery supplying 9 volts. And you can see the current 0.45 amps. All of that in accordance with Ohm's law, with V equals to IR. Two resistors connected in series where the current flows through one resistor, and that there's no branching going on, and then it flows through another resistor. And if we measure the current at any point in this circuit, we should see that it would be constant. Let's consider the example of a parallel circuit with the resistors connected in distinct branches. Here we have a case of resistors being connected in parallel. This time we get some interesting differences in the current at different points in the circuit. The current that goes through at different points varies. So this is a key difference between the series circuit and the parallel circuit. Go to Phet Simulations, open the DC circuits section, and using the schematic option, set up the following circuits. 3 resistors in series, each of resistance 10 ohms with an electric potential difference of 6 volts. Now you can right click to change the voltage and the resistance. Then I would like you to make a screenshot of your circuit, measure the current in the circuit, and use the reading that you get for the current and Ohm's law to solve for the resistance in the circuit. And then the answer that you get using Ohm's law, I want you to consider if this is equal to the sum of the 3 resistors. And then you move to 3 resistors in parallel, each of resistance 10 ohms again, with an electric potential difference of 6 volts. Make a screenshot once more, but this time it's important to record the current in each branch of your circuit. And you will see if there is any difference in the current through the circuit at each of these points, so that you will be able to answer the question, how is this reading different from the points on the circuit with no branching? What do you conclude about the combined resistance of resistors in parallel? Is it equal to the sum of the resistors, or is it less than the sum of the resistors? If you said it's less than the sum of the resistors, then you have discovered for yourself a key aspect of circuits, which is that resistors in parallel are different from resistors in series. When resistors are in series, their combined resistance is a sum. But when they're in parallel, their combined resistance is governed by a different relationship. For resistors in parallel, we say that 1 over R, the sum of the resistors, is equal to 1 over R1, the resistance of the first resistor, plus 1 over R2, which would be a second, plus 1 over R3. Taking an actual problem now for 3 resistors in parallel, 3 ohms, 5 ohms, and 6 ohms, we see that they have a common denominator of 30. So 3 goes into 30 10 times, 5 goes in there 6 times, and 6 goes into 30 5 times, giving us 21 over 30. It follows that R would be equal to 30 over 21. And we can solve that as a decimal and get our answer in ohms.